Welcome everybody to solving more complex logarithmic equations. So we're going to start with a type of problem that might have a log on each side, just a single log on each side. So log of whatever equals log of whatever else, something that looks like that, for instance. As long as these logs have the same base, all you have to do is cancel the logs and then use reverse PEMDAS. So we're going to do two of these together, and then you're going to try the other two yourself. So starting with number 1, I have log, and of course it is base 10. Just remember that if there's no base written, it's base 10. Log base 10 of 3x minus 5 equals log base 10 of x plus 2. So my bases are the same, and I have just one log on each side. That means I can cancel out the logs and just set the arguments equal. So that gives me 3x minus 5 equals x plus 2. Then I have to cancel one of the x's out, and I'm going to cancel this one out. And then I want to see if there's anything I can add or subtract to get that x alone. So I'm going to add 5. And then finally, I'm going to divide by 2. Now, do plug that back in to the logs and just make sure it doesn't give you an undefined. This one won't, but you would just put log of 3.5 plus 2 and just make sure it doesn't give you undefined. All right, I'll leave number 2 for you. Just remember ln is log base e, so don't panic because it looks different. You just do the same thing. Number 3, log base 2 of x minus 10 equals log base 2 of 6x. So I have one log on each side. They're both the same base, so I can cancel the logs and set the arguments equal. So x minus 10 equals 6x. I have to cancel one of the x's, and I'm going to choose to cancel this one again. Just that x by itself. So negative 10 equals 5x. Be really careful. A lot of you would be tempted to just forget that negative sign exists. And it does exist. You have to put it. Don't forget it, please. It will give you the wrong answer if you leave it off. And then divide by 5. So x is negative 2. Now, go ahead and plug that back in to your logs. Either one. Either one or both. Up to you. Press enter. Oh my gosh, what does that mean? Non-real calculation. That's like saying no real solution. There's an imaginary number solution maybe, but there's no real solution. So this is extraneous. So that's an extraneous solution. No real solution. So actually your answer to this one is no real solution because this one is extraneous. So just be on the lookout for that. It's going to happen again on one of these two. I'm not going to tell you which one, but it's going to happen again on one of those. So I would suggest pausing this video, trying these two, and there is an assignment that goes with these, a partial assignment. You have like 6 problems or 8 problems, something like that. They'll look like this. And then going back to doing the rest of the video. So I will see you in a little while. Welcome back. So hopefully you have done the problems where you have one log on each side of the equation and kind of gotten that out of the way, practiced that, and you are ready to keep going to our last type of equation. So in this case, if you have more than one log on a side, we're going to combine the logs first, then use reverse PEMDAS. So you are going to want to have your log rules handy. You are not going to have to memorize them this year, so keep them with you, keep them close by. So this is in a case where I might have like log of something plus log of another thing, and that equals a number. So something like this is what we're talking about. So take a look at number 1. I've got 2 log of x plus log of 100 plus 1 equals 4. Now this right here you could just turn into 2. Log of 100 is 2. But we're going to go ahead and practice using the properties. And then just be aware that sometimes there's more than one way to do it. Don't worry about the little +1 right now. We'll get to him. So, I do want to for sure use power rule here. So I want log of x squared plus log of 100 plus 1 equals 4. Now, if you want to combine them using the log rules, remember your product rule. So if I have two logs that are being added, I can combine them into one by multiplying the arguments together. So in this case, I would be multiplying the x squared and the 100. And again, you could just replace log 100 with 2. In some cases, you don't want to do that because you're going to end up with a decimal. So let's kind of practice this way for now. So log and multiply these together, 100x squared plus 1 equals 4. All right, cool. I've combined my logs into one, and now I just have to do reverse PEMDAS. So first add or subtract anything outside parentheses. So subtract 1, subtract 1. Good. Multiply or divide anything outside parentheses to get the log by itself. I don't have anything, so I'm good. Don't have to worry about that. So then I'm at the exponent step, and I want to convert the log equation to an exponential one. So remember, if there's no base written, it's automatically base 10. So I'm going to write this right here, write this as 10 to the power of 3 equals 100x squared. And then 10 to the third power, that's just a number, so go ahead and put in your calculator if you need to, but it's 1,000, equals 100x squared. Divide by 100. Now, hopefully you remember how to cancel out a square, an exponent of 2. So you're going to take the square root of both sides, plus minus square root. So far we've got x equals the square root of 10, or x equals the negative square root of 10. Now remember, when we're doing a log equation, you got to check these two to make sure that you're not going to get an error message. So go ahead and type them in your calculator and check. And I would go back to the original to check. Okay, so I tried square root of 10 first. And I went ahead and plugged it into the whole thing, but remember what you're checking for is if the log itself is going to give you an error message, so you could just type this log part in if you wanted. And I do get 4, so I do have a good solution there. So this one's good. That one's good. Now I have to check this one. Here we go. I got it typed in. I've replaced x this time with negative the square root of 10. Let's press enter. Nope, non-real calculation. So that means this right here is not really a solution. It's an extraneous solution. Now we do have a proper solution here. So this is a solution. Yay. This is extraneous solution. So remember, extraneous solutions are not actual solutions. So if I asked you on a test or something, what's the solution to this equation, you would not list this one. Let's try one more. Let's actually do the ln one. So this is a case where even though ln of 5 is just a number, you probably don't want to put that in your calculator because you're going to get pretty ugly looking decimal. In fact, it's going to be one of those decimals that goes on forever. So I would use your log rules to combine these. So I'm going to do power rule first. I see power rule right here. So remember power rule, if I have a number in front of my log, I can bring it up as an exponent in the argument. So do that. So I have ln of 5 plus ln of x squared equals 3. And then adding two logs together, so adding two logs together To combine, you can multiply their arguments. So I'm going to go ahead and do that. So I'm going to do 5 times x squared, which is just 5x squared equals 3. And now that my logs are combined, I'm ready for reverse PEMDAS. So let me write that out. So first, add or subtract anything not in parentheses, and there's nothing to do that will help me. Then you want to multiply or divide anything that's not in parentheses, and again, there's nothing there to help me. So now I want to do my exponent step, which in this case means convert the log equation to an exponential one. So my base, remember base for ln is e, so base e to the power of 3 equals 5x squared. And if you need to, you may want to write this up here. Log base b of y equals x turns into b to the power of x equals y. So if you need that there, go ahead and put it there for yourself. And then e to the third, remember, is just a number, so I can put that in my calculator later and divide by 5. So I have e to the third over 5 equals x squared. Now I'm going to go ahead and put that in my calculator and get an estimate for it. So x equals something, or x equals something else. So I put that in, and remember you do have a plus and a minus, so I get 2.00427 or negative 2.00427. Oh, you can't see what I wrote. There you go. Now, what do we need to check for? All right, so plug that back in. Again, you can just plug it back into this log part and make sure it doesn't come out with an error message. So my positive solution works out fine. It does not give me an error message. I did, in fact, get the right solution. It comes out to 3. So yay, this one's good. That's a solution. Now let's check the negative one. Oh, non-real calculation. Check that out. So this is extraneous. It is not actually a solution to this equation, so just be real careful and make sure you check for that. All right, there's, of course, the rest of the assignment that you had already picked up, most likely, to complete with this. Let me know when you are finished with this so that I can get you into a small group for help.